Section 11.4, Volumes of Prisms and Cylinders. Theorem 11.4 states the volumes of prisms is the product of the area of a base and the height of a prism. Here I have the volume equals length times width times height, or the volume equals the base times the height. In this case, we have a rectangular prism because I know the base is rectangular. We identify B as the base. And here, I have the base equal to L times W because it is rectangular. This will change depending on the polygon of the base. Here they want me to find the volume of each prism. In the diagram, I'm given a rectangular prism. The base has a length of 12 and a width of 5. I know the height is 10. Therefore, when I substitute into my volume formula, the base is going to be length times width and the height is 10. Therefore, when I substitute 12 times 5 times 10, and I get 600 millimeters cubed. And notice the units are cubic units because I'm talking about a three-dimensional object. Millimeters times millimeters times millimeters would be millimeters cubed. Again, they want me to find the volume of my prism. Here, I'm given, again, a rectangular prism. I know that because if I superimpose the other part of my prism on top, I can see that this would be a full prism, but they cut it in half. Therefore, I still have a base that's going to be length times width, and I have a height of 36. But what I need to do is take the volume of a full prism and then cut it in half by multiplying by 0.5 or a half. Therefore, I have my volume equal to base times height, which is 27 times 8, which is the base, times the height, which is 36, and then multiplying by a half. When I do that, I'm going to get 3,888 centimeters cubed. Here, I want to find the area of my triangular prism. I know that because my bases are equilateral triangles, as we have identified by the tick marks in our diagram. Therefore, what I need to do is to find the area of that triangle. Remember, the area of a triangle, which is here going to be the base of my prism, is going to be equal to 1/2 the base of the triangle, which I know is 4, times the height of the triangle. Recall the height of a triangle is a perpendicular segment from a vertex to the base. I need to determine that value. Here I know that this is equilateral, therefore each angle is 60 degrees. Therefore, when this altitude is dropped in my equilateral triangle, I know that this gives me a 30-degree angle. And I know it bisects the base, so this is 2. Recall from our 30, 60, 90 triangle that I need to find the long leg, which is opposite my 60-degree angle, is equal to my short leg, which is 2, times the square root of 3. Therefore, my long leg is 2 square roots of 3, which is the height of my triangle. Therefore, I can determine the value of the area of my triangle for the formula. Therefore, when I substitute back in, my base is equal to 1/2 times the base of the triangle, which is 4, times the height of the triangle, which is 2 square roots of 3, times the height of the prism, which is 18. And when I substitute into a calculator, I get 124.7 inches cubed. Theorem 11.7, volume of a cylinder. The volume of a cylinder is the product of the area of the base and the height of the cylinder. So this should look very familiar. We still have volume equal to base times height. But in a cylinder, our base is going to be a circle. And our area of a circle is equal to pi r squared. Therefore, when I substitute back in, pi r squared is the area of our base times the height. On this example, they want us to find the volume of each cylinder in terms of pi and then to the nearest tenth. Here I have my formula, V equals pi r squared. Recall that pi r squared is the B for my formula of volume equals base times height. On my cylinder, I have a diameter, which is 12 centimeters. Therefore, I know that my radius is half of that, or 6 centimeters. and I have a height of my cylinder, which is going to be 20. When I substitute into the formula, I'm going to have V equals pi r squared. Our radius is 6 times the height, which is 20. They first want me to solve this in terms of pi. Therefore, I multiply 6 squared times 20. I get 720 pi centimeters cubed. Then I substitute into a calculator. I get 2,261.94. Rounding to the nearest tenth, 2,261.9 centimeters cubed. Here I have an oblique cylinder. That means that it is not a right cylinder, which means the lateral face of the cylinder is not perpendicular to the bases. But all I still need to do is substitute into my formula. V equals base times height. And of course, the base is a circle, so it's pi r squared for the area of that circle. In my diagram, I have a radius of the circle for both bases to be 3.5 centimeters. And I have an altitude drawn on the exterior of my cylinder to be 7 centimeters. That's my height. Therefore, when I substitute in, V equals pi r squared 3.5 squared times the height to be 7. Again, I want to solve this in terms of pi first. So therefore, I multiply 3.5 squared times 7, 85.75 pi centimeters cubed. Then I substitute into a calculator. I get 269.39, rounding to the nearest tenth, 269.4 centimeters cubed. For this example, they want me to find the volume of each figure to the nearest tenth. Notice I have a rectangular prism with a base of 8 by 10 and a height of 6. But in that prism, I have another prism that has been cut out of it. And the base of that rectangular prism being cut out is 4 by 8 and a height of 2. To solve this problem, I want to find the volume of the figure. To do that, I'm going to find the volume of the total object. I want to find that volume by assuming this chunk of rectangular prism is not taken out. So therefore, I'm going to use 8 by 10 by 6. Then I'm going to subtract out the missing part, which is the small prism taken out on top, which is 4 by 8 by 2. When I do that, it's going to look like this. I have the volume of my total object, which is 8 by 10 by 6, minus the volume of the missing prism, which is 8 by 4 by 2. Using a calculator, 480 minus 64, or 416 millimeters cubed. Again, we want to find the volume of the object. On the previous example, we had a prism taken out. On this object, we have a prism and a half a cylinder. Now what I want to do is combine the two volumes. Therefore, we want to find the volume of the figure, and in this instance, it will be the volume of the prism, which I know is a rectangular prism. The base is 8 by 9 and a height of 15. I want to add that to the volume of half a cylinder. And my cylinder has a radius of 4.5 and a height of 15. Therefore, when I substitute into the formula, I'm going to get the volume of my figure to equal the volume of the prism, which is 8 by 9 by 15, and the volume of my cylinder, which is pi r squared times the height, which is 15. So here's the area of my base, pi r squared. The height is 15, but I multiply by half because I have half a cylinder. Substituting into a calculator, 1,080 for the prism, plus 477.1 for the half a cylinder. Combining, I get 1,557.1 millimeters cubed.